If we return to our diagram of the life of a SQL statement, we're reminded that for every SQL statement Oracle executes, Oracle must have an execution plan which tells Oracle all of the individual steps that must be performed in order to process the query. This execution plan is created by the Oracle Optimizer and is shown in step 2 of this diagram. It is primarily this step that we will focus on throughout this module. We'll start this module by understanding this process in depth. When the Oracle Optimizer creates an execution plan for a SQL statement, it must examine all of the different ways that it can process that statement in order to come up with the most efficient one. The first part of this process is for Oracle to gather all of the information about the tables involved and any indexes that could potentially be used from the Oracle Data Dictionary. To read this data, internally, the Oracle Optimizer will execute over 50 queries against data dictionary objects, and possibly more, depending upon the complexity of the SQL statement it is attempting to analyze. Then, the optimizer takes all of this data and evaluates all of the ways in which the SQL statement could be performed. This part of the process includes evaluating database statistics in order to make decisions about if an index should be used, how to perform any join operations, and what order the table should be joined in. The final phase is to take the most efficient plan and store it in an area of shared memory known as the Shared SQL Area. In real time, this process happens very quickly. However, parsing SQL and determining the best execution plan does tend to be CPU intensive. And you also have to remember, Oracle isn't just processing a single SQL statement at a time. It is processing hundreds or perhaps thousands of statements every second. Taken together, parsing all of these SQL statements can take up a significant amount of system resources, especially CPU. The Shared SQL Area is a segment of shared memory in the database where Oracle caches execution plans. You can think of the Shared SQL Area as being similar to a large hash table. For each SQL statement, Oracle will calculate a unique key by using a hashing function, and then store the parse SQL and the execution plan in the Shared SQL Area by that key. The amount of memory allocated to the Shared SQL Area is finite, so Oracle manages the Shared SQL Area using a least recently used algorithm. This means that execution plans that haven't been executed recently will be removed from the cache in order to make room for new incoming plans. Therefore, at any given time, the contents of the Shared SQL Area will vary. Frequently executed statements will most likely always be present, and SQL statements that are only executed a few times a day tend to have a shorter lifespan and be removed from the cache. When a SQL statement is submitted to Oracle and the Oracle Optimizer needs to determine an execution plan, it will first examine the Shared SQL Area to see if an execution plan already exists for this SQL statement. To do this, Oracle will use the same hashing function to calculate the hash key on the text of the submitted SQL statement, and then, much like you would do in a hash table, perform a lookup by this hash key in the Shared SQL Area. If a matching execution plan is found, Oracle can simply read this execution plan out of the Shared SQL Area and continue on processing the query. If a matching execution plan is not found, then the Oracle Optimizer will go ahead and generate an execution plan for the SQL statement. The actual details of the comparison are a little bit more in depth than this, because Oracle has to account for things like two tables with the same name but located in different user schemas. But this covers the essentials of how the Shared SQL Area works. Why does Oracle cache execution plans in this way? The short answer is that generally, applications contain a relatively small number of unique SQL statements, and they just execute these same SQL statements over and over again with different parameters each time. By caching SQL statements and their execution plans, we see two benefits. First, we save computing resources on the database server because we don't have to regenerate an execution plan each time, and this frees up these resources to perform other work in our database, like actually processing our SQL statements. Second, we'll actually see each SQL statement run slightly faster after its first execution. The reason for this is because looking up an execution plan in the Shared SQL Area is faster than regenerating a plan from scratch. Oracle is not the only database to make use of caching SQL statements and their execution plans in this way. While some of the implementation details vary, you will find the same strategy used in all of the major relational database systems in use today. When Oracle is able to match an incoming SQL statement to an execution plan that is already in the shared SQL area, this is called a soft parse in Oracle terminology. If Oracle has to generate a new execution plan for a SQL statement, this is called a hard parse. You will see the terms soft parse and hard parse used consistently throughout the Oracle documentation, books written about Oracle, and blog posts, so it is important to be familiar with these terms. There will always be some level of hard parsing that needs to go on for an Oracle database. After all, there will always be a first time when a statement is submitted to Oracle, and on that first time, Oracle will have to hard parse the statement. The idea, though, is to minimize the amount of hard parses you do and maximize the amount of soft parsing that goes on. In Module 7, we'll examine how you can use $views to tell how much hard parsing your system is doing and what the ratio is between hard parsing and soft parsing. Being able to monitor this ratio on a system-wide level gives you a good idea of the health of your Oracle database and lets you understand if there are any bottlenecks forming due to a high hard parse count. But for now, understand it is hard parsing that we want to avoid, and make sure that Oracle can soft parse as many of our statements as possible. There are a few loose ends about the shared SQL area that we need to spend a moment to wrap up. First, you might be wondering about the size of the shared SQL area and how many statements can be cached. The answer is that the size will vary from system to system, based on parameters like how much memory is available to Oracle and some configuration parameters set by the DBA. But generally speaking, the shared SQL area is sized sufficiently that it can contain several thousand SQL statements and their execution plans. Second, it is important to know that the shared SQL area is shared across all users and all applications that are using a single Oracle instance. So if you have multiple applications that are using a single Oracle database as a backend, all those applications are using the same shared SQL area. This has implications we'll discuss in the next section, because if one application is doing a lot of hard parsing, it can by itself create a lot of contention around the shared SQL area, and this will in turn affect other applications that are using that same Oracle database. Third, if you regenerate statistics on a database object, whether a table or an index, Oracle is smart enough to invalidate any execution plans that use that object and remove those execution plans from the shared SQL area. The reason why is that now that new statistics are available, the Oracle Optimizer may determine a different execution plan is more efficient, so we don't want to keep that old execution plan around. This is something that Oracle manages for you internally, and no action is required on your part. Finally, there is a way for a DBA to manually flush the shared SQL area while Oracle is running and remove all of the cached SQL statements and their execution plans. This is something that you probably never want to do on your production server, but it can be useful in test environments if you're running some sort of performance test and you want to make sure that you're starting from the same point each time.